Welcome everybody to the Solo Dev. Today we want to talk about how we can speed up your game by speeding up your animations. And so to do this, we're going to do something different than what you normally see throughout the samples on YouTube, as well as just the samples that Epic puts out. All the samples typically use Blueprint, and all the samples use the normal update anims event that is, the normal tick. What we're going to do today is we are going to set up a base animation class that actually uses the multi-threaded animation update event, which allows your functions, your thread safe functions and updates of your variables to be evaluated simultaneously on available worker threads. This, in theory, will speed up your game as those updates are happening simultaneously and not one after the other. So let's get into it. Alrighty, we're going to launch the Unreal Editor. We go into Games. I've chosen a third-person project. We're going to want to make sure it's C++. You save it to whatever folder you want to, and you give it your project name. I've given mine my sample project name, CPP Anims, and then you hit create. Now I've already started my project, so we're just going to jump into that one. Okay, when we create the project, we're going to arrive in our editor. You also will have your Visual Studio Code or Visual Studio open as well. So we want to replace the animations base class. So let's open our ABP Manny, ABP underscore Manny. And if you go to class settings, you see it's using the anim instance, which is default built into the engine. As you see here in our event graph, the first thing we do in initialize animation, we grab the character that's attached, the owning actor, the character, and that store that character, and then we grab the character movement component and we store that in the variables, and you can see these two variables here. In the update animation event, which is the tick that happens, it happens every tick on a game thread, we are grabbing velocity, the ground speed, should move, and is falling variables, and we're updating those variables on every tick, and you see the variables here on the blueprint. So what we're going to do is we're going to replace these with a base class that is actually going to do this in C++. Now, what I'm going to show you can be done here in the functions override here. If you look here, there's the thread safe update anims. And within this, then you can do the property. Where is it at? The property access here. And then you can operate or set up variables or set up the updates of your variables. This is a thread safe method. This is what allows things to happen simultaneously. But we don't want to do it here. We're not going to do it in Blueprint. We're going to do it in C++. So let's jump over to the C++. So I'm using Visual Studio Code, but it's going to be similar if you're using Visual Studio. And what I have here is I've created a folder called Animations, and I've created two files, the header file and the CPP file. I just called it TT underscore animation instance base. You can call it, whatever you want to. So our class here is UTT underscore animation instance base. And it derives from the UNanim instance, and that is our include here. And then we have our character movement component include, because we still want to grab the character movement component, right? Okay, so we have our constructor here, which passes in object initializer. We have a thread safe function called get movement component. Now this is going to allow us to get the movement component in a thread safe way and use it within the blueprint. velocity, ground speed, should move, and is falling is the variables that we're going to replace. They're now going to be on our base class, so we don't have to we don't have to set them up in the blueprint. We have a begin destroy function, which is called when this class is being destroyed. The native initialize animation, that is the animation event here, the initializing of the animation event. And then we have the native update animation event, which is basically this here. And this is our normal one that's on the game thread tick. And then we have our thread safe update animation. And that's the one that we're going to be using. This is the one that allows us to update these variables on the update the variables on the available worker threads. So there's multiple available worker threads. This allows it to happen simultaneously. And this is where you get that speed increase. And then this is our private cache movement component that we have that's private on the class. So we go over to our implementation here. We're bringing in the actor, including the actor. We're including Kesmet animation library. We're also bringing in animation runtime and the anim instant proxy classes. So here's our constructor, and in our constructor, we're setting the use multi-threaded animation update. This is what turns that on and lets the engine know we want to update our animation on all available worker threads so that the things are happening simultaneously. That's key here. So our initialization animation, this is where we grab the owning actor. We try to get our pawn owner, which we put into an owning actor variable. If that is true, or if we do have a pawn owner, then we grab the owning actor, and then we get the character movement component class by finding that component by class, and we set our private cached movement component. We have this here so that if you want to within the blueprint also do native updates that are not not in a thread safe way, you can still do that by putting things in here or just within the blueprint itself, and kind of just ignore this. And then this is where we are updating the native thread safe update animation. So we call our super. We make sure we actually have a component that's valid. And then we set our velocity from our cache movement component. We grab our ground speed based off the velocity. Then we get our current acceleration from our cache movement component. And that allows us to determine if we should set the should move flag to true or if we should set it to false. Then from the cache movement component, we set our is falling variable. And so this is equivalent to what you are seeing here. These nodes here, even down to the greater than 3.0, all those things, this is the equivalent of it in C++ in a thread safe function. Then we do our begin destroy, allows us to clean up our cache movement component so it's not stuck in memory. And then this is our implementation of the get movement component, which allows us to get that movement component in a thread safe way. So if we bounce back over to the editor, let's create a duplication. Let's save everything. Create a dupe of Manny, ABP Manny. So we'll open up our duplication here. And what we can do in class settings, parent class, we change it from the built-in anim instance class to our TT animation instance base. And you'll notice that all the variables have gone away. It created a dupe of ground speed, not kind of sure why. But so all of those are gone now. So we could continue to update using the normal update animation event, but there's no need because we're setting those variables in C++ now. So we can get rid of that, and we can get rid of our initialize animation as well. You see, we're still compiling because the variables are still there. But we do need to make one change in this sample. Go over to location or locomotion, and to walk run, the ground speed variable is gone. Now that I think about it, that's why I created that duplicate. And then when I deleted the duplicate, it removed it from here. So we need to do get ground. There we go. Get ground speed, our variable. Plug that in. Compile. And now we have the same animation blueprint that's now updating our variables in a thread safe manner, increasing our performance. And if you notice, we can put, say, 350 ground speed and say should move. And you can see that it updates and our animation is moving and everything is working as it should. Awesome, guys. So if you found this to be helpful, please hit a like on that. That truly helps me out on this new channel. And hopefully in the future, I can do some more animation events. But as I start to learn more and more about Epic and doing C++, I'm going to put out more videos to help others that are interested in creating their game or moving their game from Blueprint over to predominantly C++, or just starting a new game and really wanting to do it more, do more of it in C++ than Blueprints. So that is my goal, and I will help you guys with your same goal out. Thanks. Talk to you soon.